Welcome to A Math Tutorials with Littlemusicbear Binomial Theorem Part 2, questions 5b and 5c. Okay, so for Part B, you'll need the answer for Part A, which can be found in my previous video, Binomial Theorem Part 1. So, the answer we get from Part 1 is this, plus ... But now, Part B requires you to expand and find the coefficient of p squared. So, which means we will have to continue the expansion. For normal questions, they will then ask you to find descending powers, then find the coefficient. But this, since we'll be doing more practice, so I'll make it more complicated, so we'll have more things to expand. So here we end with 5 choose 3, 2p to the power 2, negative 3 to the power 3, so we'll continue this. 5 choose 4, 2p to the power of 1, which we can just leave it, it's not necessary, and negative 3 to the power of 4 plus negative 3 to the power of 5, because 5 choose 5 is also equals to 1, and 2p to the power of 0 is also equals to 1. Then we'll need to find out what this is. So I'll copy the terms first. Plus 5 choose 4, which is key in the 5c for on the calculator, which is 5. So 5 times 2 times negative 3 to the power of 4, you get a coefficient of 810. So plus 810p, then minus negative 3 to the power of 5, you get negative 243. And there is full expansion. Now, we're going to find what is 1 plus 2p, 2p minus 3 to the power of 5. So 1 plus 2p, 2p minus 3 to the power of 5 equals, now you're going to open up. We're going to change the order upwards. So it'll be negative 243 plus 810p minus 1080p squared plus 720p cubed minus ... because we don't need extras. Now, we are going to see which of these terms multiplied together give us p squared. So first one, we have 1 multiplied by negative 1080. So this is our first one. So it will be 1080. So secondly, we'll have 2p. 2p multiplied by p. So it will be 1620. Then we're going to calculate it. Equals to 540. Now, we're going to double check to make sure that there isn't any other terms that could form a square. Okay, so the answer for this is 540. Now we'll move on to the next part. Find the term containing p to the power 7 and 4 plus x divided by 2 times to the power 12. Okay, so for this, it's a totally unrelated question. So if you ever get stuck in the questions on top, you can still continue to proceed. For this, we'll need to use the general term formula, which is tr plus 1 equals to n choose r, a n minus r, b to the power r. So now we need to find term containing p to the power 7. That means our r is going to be equals to 7 and our n is going to be equals to 12. N is always the power and r is the power of the term we are going to find. So we sub in t 7 plus 1 equals to 12 to 7. A is 4, so we're 4, 12 minus 7, and b is x divided by 2 to the power of 7. And we're going to equate this. So always remember, the general term formula can also be used to find a particular term, not just the general term. And if they ask you and you get stuck, this formula is always useful. So 12 to 7 is equals to 792. 792. 4 to the power of 12 minus 7 is 4 to the power of 5, which is 1024. Then x divided by 2 to the power 7, we are going to split this up into x7 and half to the power 7. So eventually we're going to get half to the power of 7x7. So 1 out of 128 x to the power 7. And you're going to equate this and you'll get your answer. 792 times 1024 times 1 out of 128 equals to 6336. And remember, x to the power of 7, and there you go, you get the term. And that's it for AMF tutorials with Littlemusicbear, and we'll probably see you next year. But before I end this last episode, since I have a request to go through change of base formula for logarithms, I will show you that quickly. So it's just the formula. So if you understand, have a look first. Log 2 8 equals to 3. This means that 2 to the power of 3 equals to 8. So which means that if log x 12 equals to 2, that means x to the power of 2 equals to 12. And if we want log 2 8 in the form of log base x, it will be log x8 divided by log x2. And that's it. And wishing you good luck for your A Math end of year examinations. And please, no more F9s in this class. Goodbye.